Hey, what's up, Algebra 2? It's Ryan. Today we're going to be working on quadratic word problems. So in the very first lecture I did on quadratics, I said it can be applied and it's going to show up on a number of different things, right? I said they're going to be super common on SAT math problems. I also said that they're going to be super useful when we're talking about modeling launching projectiles. So that means throwing a ball or launching a rocket. Quadratics are going to come into play during those problems. And the majority of these word problems are going to be about launching a projectile. And if you ever take physics, you're going to have to be pretty comfortable with quadratics too. So definitely listen into this lecture. And I'll also say that these sorts of word problems, these quadratic word problems, show up on the SAT. I know on the last SAT I took, it had a problem like this. So definitely listen in, because by absorbing the information I'll be presenting in this lecture, that's going to help you study for the SAT. Even though you're directly studying for Algebra 2, it's adding to your knowledge for the SAT. So definitely listen in. And yeah, also throughout this lecture, we'll be using a TI-84 calculator. So we're going to be going over how to use your calculator, some of its capabilities. And if you are taking the digital SAT has Desmos, and you're allowed to bring in your own handheld graphing calculator. So that's another reason why this is super transferable to the SAT. Okay, so let's read this first problem. It says a model rocket it's supposed to say is launched from the roof of a building. Its flight path is modeled by h equals negative 5t squared plus 30t plus 10, where h is the height of the rocket above the ground in meters, and t is the time after the launch in seconds. Okay, first let's graph this. So I'm going to go over to my calculator. I'm going to press y equals. And here I'm going to input our equation. So it was negative 5. And here we have h and t as our variables. I want my h to be my y and my t to be my x. So I'm going to say y equals negative 5x and then squared. Then it's plus 30t plus 10. Plus 30t plus 10. Okay, great. Now I'm going to graph this function. Okay, so we see that it's not within the entire function, or at least the vertex, which is an important piece of information, is we can't see all of it. So I'm going to press window, and our y maximum right now is set to 45. I'm going to set that to 75 and see if that helps. Boom. Okay, we see everything now. So we're asked, what is the rocket's maximum height? Now, in this case, we can see our rocket is launched here. It's starting a little bit above our ground. It's actually starting at 10 meters, I believe it is. And we're launching it into the air, and it goes up, and it goes up, and then it comes down. Okay, so we're asked for the maximum height, which is going to be around here. And the way we find the maximum of this quadratic function is by doing second trace, which is calc. And we scroll down, we press maximum. Now it asks for us to do left bound and right bound. To be honest, it does not really matter. If you just get really close to the point and you press that point, you should be good. But we see that our maximum is at about 55, and our x value is about 3. So our maximum height, right, is going to be our y value. H is our y value. And here we said our y value is 55. So I'm going to say 55 and it's always important to put units. So I'm going to say 55 meters. Okay. And some of these I might not show. I'm going to circle that again. I might not show all of my work on this paper. You should, but I'm just going to talk you through it out loud and go through it on the calculator. When does the rocket reach its maximum height? Well, that's going to be our time component. So after how many seconds does it reach our maximum height? If you look here, it gives us the answer. It's 3 seconds, because after 3 seconds we get to 55 meters above ground. So 3 seconds. Okay, when does the rocket hit the ground? So it hits the ground at 2 points, here and here. Now this is negative. We have a negative x value. So that's negative time, which I wish I could go back in time, but nobody really can, at least not yet. So the point where it reaches the ground, it touches the ground, is over here. And the way we're going to find that is by doing second trace again. And we're going to do 0. So we scroll down to 0, we press enter, and we go to left bound. So go all the way here, left bound, right bound, and right in the middle. And we get that point, 6.317-ish. So I'm going to say, it says when does it hit the ground, so that's referring to time, and we see that that's our x value, so I'm saying 6.317. You probably don't have to go to 3 decimal places. I think 2 would suffice, but I'm just going to be exact. Okay, perfect. Now we're using a calculator, and using a calculator obviously gives you an advantage. You can do it a lot quicker, a lot easier. You don't really have to do any math, and you'll still get the right answer. But the way we would do this if we don't have a calculator, right, we do negative b over 2a to find our axis of symmetry, which is when our rocket reaches the maximum height. So we'd get 3, and then we plug that in to get 55, and then we probably would not be able to factor this, so we'd have to do quadratic formula, and eventually you'd get something like this. But it's much easier to just use the calculator. Okay, let's do this second problem. So a water balloon is thrown into the air so that its height in meters, h, after t seconds is modeled by h equals negative 4.9 t squared plus 27t plus 2.4. How high is the balloon after 1 second? So I'm going to go back here. Now the way we go back to our home screen is second mode. I'm going to press y equals again, and I'm just going to press clear. So we had negative 4.9. By the way, a negative sign here is different than our minus sign here, so be mindful of that. X squared. We had plus 27t plus 2.4. Oops, my bad. Plus 27t plus 2.4. Let's just make sure that's correct. Okay. Now I'm going to graph it. You know what, maybe I'm going to zoom in a little bit. I just do Z-box. So if I move this up, right, you know what, how about we go right here? We should be fine without it, but I like it better. Ooh, my bad. I'm tripping. Okay. Something like that. Okay, so it's asking for what is our height after 1 second. So what I'm going to do is I'm going to press second trace, and I'm going to do value. So remember, our seconds mostly when we're launching projectiles, time is going to be on the x-axis, then height or some other variable is going to be on the y-axis. So we're inputting a x value, and our time is 1, so I'm going to put x equals 1. And we'll get a point, we'll get a y value in return. And that's 24.5. So we're going to say 24.5, and we have meters, so I'm going to say our height after 1 second is 24.5 meters. Oops, my bad, that's real bad. Alright, okay. Now we're asked to find the vertex of the parabola. Write a complete sentence interpreting what the vertex means in relation to the context of the problem. So we want our vertex. How do we find our vertex? We talked about this before. Just think about it in your head. If you have a calculator there, maybe do it on your own calculator. Well, we do second trace, and since this is a parabola facing down, right, our a value is negative, we're gonna go to the maximum. We're gonna estimate that, something like here. And we get a maximum of 2.755, at 2.755 seconds, we get a maximum height of 39.594. So that is going to be our vertex. Those are the coordinates. I'm not gonna write that down. I'm gonna say the balloon reaches a maximum height. Sorry, for some reason this is weird when I write. Of, is it 39.594. Yeah. Oh. 39.594 meters. I'm just gonna say at 2.755 seconds. 2.755 seconds. Great. When will the balloon hit the ground? We talked about this before in the last problem. Think about how you would do that here. Well, we're gonna do second trace, 0. We're gonna scroll here. We get to our left bound, our right bound, in the middle. We get a 0 of about 5.598. It's probably 5.6, but you know what? I'm just gonna say 5.60. So that's still bad. 5.60 seconds. I'm gonna write that again. I'm sorry, my circling isn't great. Okay. Now, one thing I will say here, I'll talk about another way to do this in a second. Here, notice our y value is this -1 e -11. That's just talking about -1 times 10 to the -11th power. Basically, it's just really close to 0, but it isn't close enough for this calculator to say 0. That's why I ended up just saying 5.60, because this was a little bit off. So, I bet this is going to be a little bit off. Real quick, another way to find the zeros of a function, I'm going to press y equals. I'm going to go down and I'm going to do 0. I'm going to graph this. You'll see that goes right along our x-axis. So I'm going to press second trace now, and I'm going to scroll down to intersect. Now I'm going to go here, first curve, about like there, second curve, there, guess, there. We get 5.598. I probably should have said 5.598, but it's chill. And that would be another way to find the zeros or the solutions of a function. Okay, let's go on to the third problem. A football is punted into the air. Its height in meters, h, is given by the equation h equals negative 4.9 plus 24.5t, negative 4.9 t squared plus 24.5 t plus 1. Sorry, for a second I thought it was the same thing as up here, but nah, that's interesting. 24.5, 24.5. Okay, anyways, let's put this into our calculator. So I'm gonna go to y equals, I'll leave that 0 there. This is negative 4.9, negative 4.9 x squared plus 24.5 t plus 24.5 x plus 1. Yep. Okay, so now we're going to graph this function. Looks something like that. And we're asked, how high is the ball after 1.4 seconds? We did this before in the last problem. 1.4 seconds is going to be our x value, so we're going to do second trace value. We said 1.4, so I'm going to say x equals 1.4. We get our y value in return, so our height is 25.696. So we're going to say 25. We said 25? Yeah, 25. meters. Okay. Again, it may be good to show some work. You can't just do this all on the calculator. But just for demonstration, and I don't really want to write that much right now. On an actual test or on homework that's going to be graded, you should show your work, because if you do get the question wrong, you want your teacher to see where you messed up. Like, that's important information for them to know. Okay, does the ball ever reach a height of 33 meters? How do you know? So let's go here. How I would solve this problem is by finding the maximum height and seeing if that's more or less than 33. So I'm going to scroll down to maximum. Our left bound is like right here. Our right bound is there. Something like that. It's 2.5, and our maximum height is 31.625. Well, 31.625, I'm just going to say this. 31.625 is less than 33. And you should write this out, but I don't really have that much space and I don't really want to. But 31.625, this is the max height. So we're never going to get any higher than 31.625. So since this is the maximum height and 33 meters is greater than our maximum height, we're never going to reach 33 meters. So our answer is no. When does the ball hit the ground? We've done this 3 times. We do second trace, 0. I showed you a different way. I'm still just going to do 0. Left bound, right bound, enter 5.040. 5.040 seconds. Okay, Great. Now let's do this last problem. A carnival attraction tests your strength by how far in the air you can drive a weight with a hammer. If the weight reaches 15 feet, you win a prize. The equation h equals negative 16t squared plus 31t plus 2 gives the height in feet and time in seconds of the weight after it is hit. How long is the weight in the air? Okay, so let's input this equation. So second mode, y equals clear. We had, I believe it was negative 16. I want to say. Yeah, plus 31t plus 2. So we just input our equation. Hopefully you're getting a little bit more comfortable with this. And we get our function here. I'm going to zoom in. Oh, let's go. And this is how we do this. Okay, great. How long is the weight in the air? Well, we see that we have two solutions, two zeros, but one of our solutions is negative, right? We would have a negative x value here. We can have negative time, so we're starting from when time is 0, because our projectile, or this hammer, what is this, like a disc, whatever, it goes up in the air starting at time equals 0 at a height of 2 feet or something. So we're gonna find the other 0. Or you know what, let's just do intersect just to try this out. Basically here, and we get our other 0 is 2, 0. So the weight is in the air for 2 seconds. Great. What was the weight's maximum height? Let's do second trace. We scroll down to maximum. Left bound. Well, we can basically just estimate. It's at 0.6 or 0.96970 seconds, we get to a height of 17.016. So our maximum height is 17.016. And that's in feet this time, 17 point. Make sure to always put your units, by the way. It's important. Okay. Did you win a prize? Why or why not? Well, if the weight reaches 15 feet, you win a prize. Our maximum height was 17.016. Well, 17.016 is greater than 15. So, yes, we did. Maybe you should have a bit lengthier explanation, but still keep it succinct. Maybe write it out in word form of why we won that. We got a height greater than 15, so we won the prize. Okay, that's basically how we do quadratic word problems. Hopefully by the end of this lecture, you've become a little bit more comfortable, a little bit more proficient in not only modeling real world situations with quadratics, but also using our calculator and using all of its capabilities to help us do it in the most efficient way. Especially on the SAT, you may be able to solve some of these problems, or you are going to be able to solve some of these problems using pen and paper. And while sometimes if you like math, that's fun and you can do all these interesting strategies, but on tests and the SAT and sometimes in real life, you want to do it in the quickest, most efficient way possible. And if you have a calculator at your disposal, it's probably going to include your calculator. So hopefully you've gotten a little bit more comfortable with that. If you do have any questions on what we went over in this lecture, go to Mr. Whitaker, go to your teacher. Feel free to use me as a resource. That's why I'm here. Go to the tutoring center and definitely use the internet and online as a resource. Okay, great. Thank you. Have a good day. See ya.